Okay. Hello, everyone. Good morning. Uh, it's Sunday, and but here we are, back with our webinar for Data Science Delhi for version 2, particularly. Hello, everyone. As last in the last webinar, Zimi was a presenter, and he gave, I think, a lot of insights around the basics of pandas, particularly, all how to load the data, how to consume that data, and particularly through read CSV, which is you are able to see on the screen as well. And though I will not be reiterating it today, but this is something that this data set I wanted to use, so I used this data set. And will be and he went through all that, how to kind of access the indexes in pandas and why they are important, uh, and uh, and then he went through around, so he took some data frames and he took some basic commands like is null, what does that mean, and just check to how to check the distribution like dot describe, which she also kind of walked through you, and how to use head and tail, why to use head and tail, right? And so let me quickly jump on to uh, first thing, why pandas is important, which I wanted to understand from you as well. That have you got it? This is one thing I wanted to understand, so that you are also aware of. Okay, you are not just doing it just for the coding part, but you should understand why is there a need of pandas, uh, you know and are you actually using it in your daily projects or not. If you are not, then you'll tend to forget this, right? And later on, so one thing for sure, keep practicing it. And in how we use pandas, I mean, we pandas is a daily daily usage. It's more like, we daily use it for exploration activities, data exploration activities. Now there might be a question that somebody might ask, okay, do you also use pandas on terabytes of data? No. So what usually happens is that, okay, you basically, in majority of the products, we generally have all kind of situations where all type of data and all sizes of the data, and so there we basically, you know tend to think of, okay, where to use pandas. So basically pandas does everything in memory, and that's for sure that if you want to process terabytes of data, then so you need to have bigger machines, and so which is expensive, and so it is not feasible, right? And what we do is we generally take terabytes of data but take samples out of it. You might take random samples, you might take stratified samples, it's up to you. But over the time, as you start using pandas, you tend to know how to use it. Or even, what we do, you don't generally use raw data in the raw shape as it is, right? You first aggregate it to certain levels to build models sometimes. And so the moment you aggregate, your data sizes literally go down, and by 1 by 10x or 1 by 100x. So that's where uh, pandas come again back into picture, that you can still use pandas because it gives you all that functionality, which even if the moment you go to production, you might think of that, okay, no, I can't use pandas here, but I'll be using, let's say Spark. I will be using Dataflow to write my ETLs. Okay, first, it's always easier to kind of, while doing the data discovery or building the data or doing the data exploration activities, you just want something handy and easy to use. And so it gives you all these functionalities. the concept of data frames, which is equivalent to tables, right, for structured data. So in structured data, and so the moment you finalize you freeze your ETL, your transformations in Pandas after data exploration, you can immediately, write that, code this up into in Spark, or even, let's say, BigQuery in SQL, and because it's easier to use, very similar. The point is that, Pandas helps you write logic faster than anything else, because you don't want to, spend your money, spend your cost of servers, just to run, just to do your data exploration activities in the beginning. You can do your data exploration activity on the large data sets, but it's always good to start with smaller data sets, have a catch of the data, and then move forward, right? And some of the things that I mean, the moment you start doing it, then you start, getting its benefits. You start understanding it, why it's so. But this is just about, I'm just sharing my experience that it happens so. Okay, so what we'll be going through today, or likely we'll be going through today, is first we'll just, we'll load this data set which was last in the which we used in the last lecture as well, uh, and then we'll talk about, again, this is the same old, uh, the command that we used last time as well. To see, by default it shows top 5 rows. If you want to have a flexibility, you can send, let's say, 7, so automatically it will give 7. Okay, and then we can plot histogram, right? And I think this was plotted last time as well, and so it will be a revision for you. And then we'll take a data frame which to taken last time, and I just have some one or two plots more for you, so that you can utilize it. But here we'll be talking about, we'll have more data manipulation activities like transposing the data, and then we'll be talking about how, if how to filter the data with the help of indexes, or with the help of, let's say, some columns contain strings. So you want to filter all those rows which contains of out of which one of the columns contains certain string. Okay, so you can do that. And then an apply function, that uh, it's more like a, which I can use it as a filtering condition, so that will also go through. Then again, regex, how to use regex for filtering. And then we'll go through update, how to update certain columns based on certain filters. Basically we'll be using the filters. And then how to check for nulls. It's very, very common that we, have these situations where, immediately while exploring, we need to, just validate, because there are many functions which doesn't work if there is a null value in the rows, or there are algorithms which doesn't run, and which fail if the null values are not handled. So, you need to check where it is happening, right? Which column has this null value, so that you can treat those and, improve the data. And then about the, some, cumulative sum functionality that you can have, basically with the help of apply function. And then also using the lambda function, coding up the lambda function and apply it. So it's a great feature in Pandas, and it's very similar to what is available in Spark as well, or any other functionality. So it's more like it applies to each row and till the end, right? So then comes concatenation. Concatenation is again, these are very, very frequently used functionalities. And then comes merging part. It's more like a joins that we do in SQL. So you can think of that, think of it, I want to conceptualize my whole logic of, let's say, some filtering conditions, some join conditions and all. I don't need to, wait for all the data to be there. I can even get the sample data from my customer. I code it up, at least and then the moment in the meanwhile the customer might be getting me all the complete data into my data warehouse or data lake, and then once that is there, I already have my logic built. I can quickly build that logic, code it up uh, into whatever my production platform. So that's here. And then we'll also talk about again very frequently used, more from an analytics point of view, the group by functionality. So it's an aggregation functionality. So basically, for a certain dimensions I want to calculate some mean, I mean medians and multipliers, whatever function, that measure that I want to apply across certain indexes. So index here is name. So I'll come to that. Yeah. So I'll keep it very very simple for today. Uh, but still we'll be able to cover, I think we should be able to cover the basics in terms of that. Okay, this is something that you should never forget, and you can deep dive into all these concepts, because there is no single way to do all these commands. Even if you see that, once we go through it, you'll see that even I have written a filter in multiple ways, because it's never the same way that you filter the data. It's always whatever based on the condition that you will find in a particular use case. You always have a different use case when you have different data. At least you think it differently, and you try to think that, okay, I hope, you always have wish that, okay, I hope I could have filter my data with this column value. Okay, I hope I would have filtered this rows with the help of index number, and so on. So all that, I mean, think about any kind of these kind of logic for analytics and machine learning perspective. Everything is, I mean, at least I have not run into any situation where I'm trying to code up something and it is not available. It would be available, it's just that we don't know that right now, because there is one or the other way. And friends, Stack Overflow, please, always make a habit of exploring Stack Overflow, uh, to kind of watch for pandas and any other programming problems whenever you ran into any kind of situation. But pandas has literally lot of help on Stack Overflow. I mean, every answer is there. Even some of the examples that I've taken in between, I've taken it from Stack Overflow as well. Where Stack Overflow gave some answer that, okay, this is how you can do as well. So you just pick and choose and optimize always your data exploration. So okay, and so basically, in a nutshell, this pandas is used when you are exploring, you are doing the data exploration and building the models more from an experimentation point of view. Okay, and okay, ready to go. So let's uh, you know I'll share the notebook on the video which will be uploaded. I'll share this notebook link via the share. So you can all open this colab.research.google.com and open a Python 3 notebook. Okay, let me open this. Uh, so let me see how can I'm uploading it to. No, I will not upload, but let me do one thing. What I can do, just a minute. What I can do, I can see where this link is live, and so accordingly I can Okay, so what I can do, I can definitely share this notebook um, on this link and generate this copy link and put it on meetup.com probably, and from there you can find it. You'll get to this today. Okay. I'm putting in comments. Probably, I think, please find the notebook for today's lecture. Okay, great. So I have posted it on meetup.com. You can pick it up from there, and or you'll anyways find it at the end. And till that time, you can just follow me via the you know via the video, because I hope that you will not copy and paste these commands. I do it now because I have now got a lot of hands-on on Pandas multiple times, so I don't need to. So, but I would recommend that you just write it yourself rather than copy pasting from my notebook. Okay. So this what we are importing is for matplotlib inline, so that the moment I I want to plot something, I need matplotlib. So inline it will show the visualization, and that's why it is there. That's why write is inline. And parents we need to import, and plt we need to use as to for plotting from matplotlib. Okay. And then it's the figure size, the chart that we'll draw. So it's the parameters you can change, but okay, let me put it like this. And then comes about that, okay, let us use this public data set. So pd.read underscore csv, as you remember from the last lecture as well. You can load this data set. So whosoever hasn't gone through the last lecture, don't worry, there is not much something which is kind of dependent on that. It's just that just go through that lecture afterwards, and then for now focus here. Okay. And then let me take this command separately, and so think of it. So this data frame is loaded. Okay, so this data is loaded, and now I want to kind of understand the details around this. So maybe I can write dot columns, right? So to tell me what all the columns are available in this. Okay, and plus I want to probably see the details around this. Okay, the statistics, the basic statistics on numerical columns. Whatever will be the numerical column, that will give me the by describe function, it will give me the statistics and min, max, standard deviation, and such kind of thing. See how many rows are there in this. What is the mean of those this column? So essentially, for lat long it doesn't make any sense, right? But for the other columns, it makes sense that okay, what is the minimum? Okay, is there any? So as you can see, population 3. Is it possible to have population of 3? We need to check. Household 1, so that means whatever the level the data is at seems to be little so it's not lat long. Okay, so basically for a particular lat long, it says that okay, it might be that only one household might be there, because that in that whole small lat long area, it might be just one kind of bedroom, one house, and then so the population is 3, right? And then let's see through the starting 7 rows of this data frame. Okay, and it shows us that okay, total rooms are like varying like this, and households like this, median income, median house value. Okay, And then somehow I want to understand, okay, that's fine, I want to see the distribution of total rooms in the data set, complete data set. So let me plot it. Okay, so as you can see, you know, very few total rooms. So there are total rooms which, you know, this might be in a particular location. Total rooms might be, 20,000. So either the locations are either at that particular. So it might also tell us that it is a highly densely populated area, where the kind of rooms or the buildings are very near to each other, and so a lot of rooms are, available, are kind of, located in that space, versus where, the rooms are very less. So that means that the those are kind of sparsely populated area. It might be, so it just gives an evidence of that it might be. So and then you need to check other evidences and to confirm to this hypothesis, right? And then let's create another, for today's purposes we need to, kind of create uh, another data frame, which was there last time as well. Okay, I think I have something did. Okay, so what it does is that we create. So since we know, right, data frame is a combination of multiple series and data frames. Okay, so one column makes a series and multiple columns makes a data frame. So we are taking two columns individually. One is city names and one is population, and then build a data frame out of it, these two columns. So we say that, okay, take name as the column name, and which you put up this city name series, and then population as another column name for which you assign this series. Okay, the series has size has to be same, otherwise it will throw an error, though you can handle it. But yeah, this is how. And then again, let me plot this for population cities. So you can see that, okay, I have these kind of populations, or I have these kind of populations. So I have cities with these kind of populations. Okay, and I have cities. So these are the highly populated cities, and these are the less populated cities, right? And then I wanted to think of it that, okay, here is total rooms and total bedrooms. The scales are different, but think of it, you know, city wise. You have column city wise. Let's say column one tells the number of rooms in one city and total, and here total rooms in another city, and you want to compare, and then you can use this to kind of see, okay, which say that, okay, city 1 all has less number of rooms versus city 2 which has a higher number of rooms, right? So it will tell with different colors to here. Okay, and okay, sometimes it's always helpful. So as of now, if I have a look at cities database now, if I do head, right, and when I see it, uh, it shows me something is, I haven't run this probably, that's why it is showing me like this. Okay, now if I run this, okay, so fine, I thought there was some mistake. So essentially it is not showing me all, right, and it is in too much space. So generally we use for a more readability perspective, when it is, let's say, hardly 8-10 columns, and I want to, kind of compress it through. So generally we use like this, right? So basically it has taken a transpose of it, and in Excel, right, you whosoever is good in Excel, think of it, it's just your Excel. It's just you just write your Python programs, and then you get the same functionality of Excel, right? um, and now think of it that you just want cities with a population greater than 4 million, right? Now I want this only cities. Let's say it is a huge list. it's 1,000 cities list, and now we just want the top, good number where the population is more than 4 million, right? What I'll do, I'll write cities, and then there's a square bracket. Then I'll say cities dot population, cities dot population. It should be greater than it. So please filter greater than 4 million. Okay, and then so it will filter out all those. So this is just a added thing. So the moment you filter it out, it the moment you apply this, so it's more like a filter condition. The moment you apply it, it searches for all those indexes. It returns back all those indexes where this is true, and then it returns back into this square bracket whereby this data frame gets filtered, and then you're able to see, right? So Shanghai, Beijing, Lagos, Istanbul. So San Francisco, San Jose are out of the list from here because their population is lesser than that in whatever the data says. So this data might not be accurate, but think of it, whatever the values will be, you can apply your filter technique, right?